This is one of 21 control structures. If you look across this whole field, there's 100 acres, and we're controlling water level in this farm about every 1 foot difference in elevation. So water drains that way towards the pond, and you can see we've got it shut off at the pumping plant. There's water down in there, and there's water behind there. That's just rainfall water. Okay? When this corn gets to be this tall, we will be pumping water from the pond clear to the other end of the field, and it's going to disperse. It'll take about a week. It'll disperse, and all these control structures will hold the water table in this field. So it's closed loop. It never goes to a stream. The water is harvested. I'll show you the pumping plant. The water's harvested into a pond, pumped back in, and distributed for crop use. And if we did it right, the amount of water that we're pumping equals the evapotranspiration of the crop, which is about average 0.17 inches per day. Okay, and so if you take 0.17 inches and spread that over 100 acres, you can actually determine how many gallons of water. Hence, that's how it's designed. So it's basically, it's taking bits and pieces of science and putting it all together to make a closed system. So you got 100 acres here, coming here. This is the electricity, runs the submersible pump, goes into the pond.
Completely empty the last time I was out here.
Oh, yeah,
Oh, wow. Oh my gosh. I mean, this thing is super deep.
yeah.
So that's a lot of water. Sure.
This is a 5-acre surface pond. We're taking about 7.5 acres out of production. Well, this has been designed, and it's not full yet because we've been so dry. The tile didn't run this winter at all. This was designed, believe it or not, to handle just 100 acres. That's how much water it takes. That's why overhead irrigation is so inefficient. And overhead irrigation is typically on sandy ground, and you can't sub-irrigate. That's the only choice you have. But here we've got tile and heavy ground. We can establish a water table and help increase yields. For that, I'd be able to grow 300 bushel corn here. On a Hoytville soil, the loss of nitrogen per acre, it's right around 8.3 gallons of 28% per acre. Now, if you take a gallon of 28%, it weighs about 11 pounds. Take 28% of that. That's how much nitrogen is being lost in a tile system on a Hoytville soil. Now, maybe not here, but in Hoytville research in Northwest Ohio on Hoytville soils. Phosphorus is real low. It's about, if you put it into, you know what 1034 is, 34%. It's about 8 ounces. Very small amounts of phosphorus leaving the farm. But that's a huge benefit. I mean, you know, they're looking at, because this hadn't had a crop on it in 2 or 3 years, it's so wet. Now they're going to get a crop. And when you grow a crop, you actually take excess nutrients out of the ground, right? If we can give it more crop or more water, it's going to take more nutrients. Then all that stuff is tied up in the residues, and it's stable. And then eventually gets released down the road through mineralization, things like that. Much better way to release nutrients than spreading fertilizer, right? So you don't have all that stuff going in directly in the stream that eventually works its way down to the lake, and then he gets increased yields. Plus, you know, we're not losing any nutrient. And I maintain he shouldn't have to fertilize as much.
But yeah, let's see what happens. Because it's going back onto the plants, and
It's going back onto the plants.
You went
and
swimming
gonna
on
be,
it,
right.
in it.